David Smith here with one more Flip Classroom math video. 3 tips before we start. You could turn on the captions and watch my words go by on the screen if that helps. You could also speed up the playback if you can get through the video faster and still comprehend. Lastly, you could pause video at any time and catch up on your notes. Okay, let's do some trigonometry review. We're going to do some problems. There's no new laws or theorems. We're just going to attack several different word problems with our knowledge of trigonometry thus far in our chapter. So let's take a look at this first one. There's a 10-meter tall tree and it casts a shadow on the ground somewhere that makes a 40-degree angle of depression. First step, draw the diagram. Okay, so here's my ground and here is my tree. Now, geometry diagrams should have the measurements and anything else you know thrown on the diagram. So pause for a minute. There's 3 things you can add to this diagram. See if you can figure them out. Okay, first one. Always assume that anything like a tree or a building or something that goes straight up is indeed straight up and makes a 90-degree angle with the ground. First thing. Second thing, the tree is 10 meters tall. So here we go, 10 meters. The third thing is probably the hardest thing, is to figure out where this angle of depression goes. So if you remember our definition, the angle of depression is the angle down from the horizontal. So here's the horizontal from the top of the tree, and the shadow is that, and the angle of depression is 40 degrees. Like that, okay, because it's 40 degrees down. So that's a diagram using all the information. Now there's one more thing that we're going to need for this to solve it, to do part B, which is find the length of the shadow on the ground. In fact, what I'm going to do is we'll go ahead and mark that X already. What more am I going to need to be able to find X using trigonometry? Okay, it's this angle inside the triangle. The 40 is not in our triangle, so we need to figure that out. And we know that going from the horizontal to the vertical is 90. So that leaves 50 left for inside there. Okay, now we've got a fully labeled diagram. Let's move on to part B. Find the length of the shadow on the ground. That's this length there. Pause the video, write your trig equation for that. Okay, here's the angle I know, 50. I want the opposite and I know the adjacent. Tangent is the one that relates opposite and adjacent, so that's tan 50 equals opposite over adjacent. Okay, so now pause the video and solve that equation for me. Okay, let's see how you did. Variables up high, we multiply the other 2 quantities, so that's 10 times tan 50 equals x. Then we get out our calculator. Okay, when I do the math, I get 11.92 meters. If you get something else, check your settings on your calculator. It must be set to degrees. Okay, so we got 11.92. Now let's take a look here. Does that make sense? And yes, it does. This is 10, so this is going to have to be a little bit longer than the height of the tree. And I think that makes sense. Okay, just for fun, I added a part C to this problem, and I gave you a little bit more information here. I marked our x here that we found was 11.92, and I'm giving you this new distance, this 5 more to get to C, okay? So now our problem here is to find the angle of elevation from C to the top of the tree. So that's this angle here that's going up. I'm going to call that theta. So you're being asked to find theta. Okay. Pause the video and see if you can write an equation that relates what you know to theta. Okay, let's check this out. Tangent of theta is going to equal opposite over adjacent. We know this side here. It's 11.92 plus 5. I'm just using the bigger right triangle that's in the diagram. So, tangent theta, tan theta equals opposite 10 over 11.92 plus 5 is going to be 16.92. So that's our tangent equation that relates the two sides that we know. Now, there's something we have to do to this equation so that we can solve for tangent, or for theta, because right now theta is buried in the tangent function. So pause the video and write the new equation that allows tangent out of here so that we can just solve for it. Okay, if you remember, you just have to do the inverse trig function, the inverse tan function, which is written tan to the minus 1, and we stick the numbers inside, and the theta comes out where the numbers were. So that's what we do there. Remember, to find an angle, find a theta, you just put the numbers you know, the two sides, inside the inverse trig function, and theta comes out. Okay, so now pause the video and do that calc. Okay, I did my calc, and I got 30.58 degrees. Okay, so let's take a look at the diagram. Does that make sense? And it really does. If this angle is 50, and that's 90, we know from every triangle totaling to 180, this has to be 40 degrees. Now I can take a look at my diagram. Since this side and this side here both end at the same top, we know theta has to be something less than 40. And indeed, we got 30.5 approximately. So that makes sense. Okay, let's do another geometry problem, this time with construction. And I've done a fair amount of construction in my life, and I've used geometry almost every day on that particular type of job. So it's a pretty nice application of the math you're learning in this class. Okay, so if you ever build stuff, remember your geometry. A builder is designing the roof shown here. So this is a house, and that's the roof of the house. And notice how it overhangs on both sides. This keeps the water off the side of the house when it rains. And the roofer is designing this roof here. One of the things that's super important about a roof is what is the pitch, which is actually just like the angle. It's not a slope number, it's an angle. So what we're trying to find here is the pitch of the roof, which is this theta right there. So question A is, let's find that. See if you can write an equation that would help you find theta. Pause the video now. Okay, so there's some things you've got to do before you know all your numbers. First one, I'm going to drop a vertical straight down there. And that's going to make a right angle there and a right angle there. Now, since that's a vertical, we can assume, actually, let me back up a minute. If you see a diagram like this that looks symmetrical, you can assume that it's symmetrical. So if this is 13 meters, then this is 6.5 meters, and this side is 6.5 meters. Okay? So we're almost there. I can bring that 6.5 right up to there. So I've got 6.5 meters, but to get theta, I need to get all the way out here. So this one, I would add this 1 meter, and the whole thing, the whole bottom of that triangle is 7.5 meters. Now see if you can write an equation that will help you find theta. Okay, let's see how you did. Theta has got the adjacent, that's my 7.5, and the hypotenuse, which is my 8.7. So cosine theta is going to be adjacent 7.5 over 8.7 cosine. So that's going to be my equation that relates theta to the quantities that I know. Now pause the video and write the inverse trig equation that will help you find theta. Okay, let's see how you did. That would be cosine inverse of 7.5 over 8.7 equals theta. Now go ahead and punch that up on your calculator. Okay, when I do that, I get 30.5 degrees. So that is the pitch of that roof. We can write that up here. 30.5 degrees. Okay, so that's A. Woohoo! Now let's look at B. Find the height of the roof. Okay, it's not the height of the building. In fact, we don't have enough information to find that because we need to know what that side is. And right now we haven't been told anything about the diagram that would help us figure out that. So we're going to ignore the height of the building. We just want the height of the roof. And that's this spot right here. I'm going to mark it X. This is from the top of the wall to the top of the roof. That's the height of the roof. Okay, so now See if you can write an equation that will help you find this x, the height of the roof. Okay, now the cool thing about this is that there are two equations. Actually, there's three equations that will do this. So if you want to pause the video right now, see if you can come up with the other two if you came up with one. If you didn't come up with one at all, do that. Okay, so I'm going to skip out of trigonometry. We have a right triangle right there. So we could go 8.7 squared plus, no, 8.7 squared equals x squared plus 7.5 squared. That's just the Pythagorean theorem. This squared plus that squared equals that squared. So we could solve this on down for x, and we'll get the same result as we get with trigonometry. So let's do the two trig equations. Since I know two sides, I have a choice. I can use either one in my trig equation. So I'm going to start by using the hypotenuse and the opposite. Remember, that's sine. So I can go sine of 30.5 equals opposite x over hypotenuse 8.7. Now that equation will work. Let's do the other one. I can also use cosine because I have the adjacent and the hypotenuse. So I can go cosine 30.5 equals, nope. Do you see what I did wrong? I need to use tangent because I know both of these. This is not going to help me. I need to use opposite over adjacent, so that's going to be tangent. If you caught that before I did, good job. So tan 30.5 equals opposite over adjacent. So pick one of those equations and solve it. Okay, I did that all three ways, and with the two trig functions I get an identical answer, 4.42 rounded to 3 sig figs. Using the Pythagorean theorem, it rounds slightly differently to 4.41, but that is very, very close, and that confirms that these three different equations will yield the correct answer. Okay, one more problem for this lesson. This time it's just a diagram-based problem, no word problem to tease out the meaning from. So here we have our triangle ABC. It's got a height of 150, let's call that meters, and then it's got two top angles of 30 for this one and 45 for that one. So here's your request. Find the length of BC. That would be this bottom piece of the overall triangle. So if you're feeling bold, pause the video right now. Pretend this is a test question. It's do or die. These count for your grade. Give it your best shot. There's nothing new in here. You've done all the kinds of calculations we're going to do in a minute already. Okay, let's see how you did. First off, I can't find BC directly. I don't have a right angle in this overall triangle. But I do have two smaller triangles inside that both have 90-degree angles. So if I can find this distance, which I'll call x, and this distance, which I'll call y, then I can add them together to get what they want from us, which is the whole length of BC. So if that stumped you in the beginning, pause the video and see if you can solve this problem. Okay, now I'm going to work it on through. Let's take this side first. I have this triangle here. It's got a height of 150. That's this side of it. And it's got an angle up here of 30. And I'm trying to find this side. So what trig function relates this side to that side and that angle? That would be tangent. We have tan 30 equals opposite over adjacent. No hypotenuse. So tan 30 equals opposite over adjacent. Variables up high, you multiply. 150 times tan 30 equals x. Now before I get out my calculator, I'm just going to do the same thing for this one. Again, we have tangent. Tan 45 is opposite over adjacent. So tan 45 equals y over 150. So 150 times tan 45 equals y. So let's crunch some numbers. Okay, I got out my calculator and did some number crunching. X is 86.6. And then on this one, I didn't need my calculator because I'm familiar enough with tangent, I know tan 45 is just 1. You probably noticed that when you did the calculation. So I just know automatically that this one has to be 150. Don't worry if you don't have that in memory, but as you work through and get more familiar with trigonometry, you're going to start to remember some key values of tangent, sine, and cosine that give you really nice answers, especially tan 45 is just 1. So I got my x and my y, just add them together, and 236.6 is the distance of BC, but to 3 sig figs, we're going to round that to 237. Now that you've finished, write down any questions so you can bring them to our next class and get some help. Remember that you can always watch the video again to improve your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.